ladies and gentlemen from Cologne, from EASA. We would like to welcome you to this information session, which starts at 10 o'clock and will last 1 hour and a half until 11:30 Cologne time. As you can see, the session is announced for raising awareness on the deliverable of a rulemaking task 196. The name of this task is update of the flight simulation training device requirements. And one of the deliverables within this rulemaking task is to prepare a draft new certification specifications for FSTD. Today we will have an information session that is with an objective to raise awareness to the stakeholders on the new draft CS-FSTD and to announce the key aspects of this new draft. We hope this information session will be useful for you. We have colleagues internally at EASA with us, and with colleagues who are also part of the rulemaking task, who will be our guest speaker for this information session. They will present themselves shortly. And I would like to announce that this information session is only in a mute mode for all of you as participants. It's not a discussion session. It's really to inform you about these deliverables and to explain you the next steps related to this task. My name is Nadia Ilieva, and I'm an FCL expert in EASA, providing support to this rulemaking task. And I have the pleasure today to be your host. And we have now in the rooms our managers. I'll give you the floor to our manager, Francesco Gaetani, Mr. Gaetani from our head of department, will give you some introductory words. Thank you and welcome from us.
Thank you, Nadia. Good morning, all. First of all, let me thank the team for making this happen. Christian, Nadia, Colin, Ascanio, Matteo, and of course, connected from abroad, we have Erika Only, fundamental for the successes of this rulemaking task, which has been progressing nicely during the last months. So today it's an important pillar because with this new CS-FSTD, we are introducing the FSTD signature concept. Capability signature concept, which is from ICAO on Doc 9625. Why is it so important? It gives the flexibility to have training conducted in the right tool linked to the task, and with all the complexity that this flexibility brings. We would like to use this opportunity to reduce as much as possible the complexity with a thorough understanding on how this concept will help the end users to plan and conduct efficient training. So as we can see, we have several mandates. One is, of course, for safety. And in our department, safety means training effectiveness, but also efficiency. We need to allow as much as possible the training to be conducted to the most efficient tool, and also sustainability, meaning that the more we can train on the simulator, the less we will pollute, and keeping the level of training effectiveness the same or even better. The last point is the application of new technologies. This work on the CS-FSTD will be also allowing the new technology to be, let's say, better placed and better managed through the regulatory environment. We will be the first step only. Okay? There will be more developments in the future, but we are trying to achieve something that like Oli and Enrique will explain, should bring us to certification specifications for FSTD, which are technology agnostic as much as possible, so that we can keep pace with the technology awareness. So, Ascanio, please.
Thank you, Francesco. And as Francesco said, this task is really omnicomprehensive task, and is not only looking at the FSTD capability, it's also looking at what is what are benefits in the pilot training using FCS concept and framework. And to do that, we had to thoroughly review the type rating training course, which is the very first rate training that the FCS concept will cover at the very beginning, and also to see how much we can use FSTD other than FFS. It has been a very long journey, and to do so, we had to review also the qualification of FSTD with the new CS-FSTD concept that the colleagues will going to explain very soon. And then we had also to amend the authority, but as well the organizational requirements, introducing also tips on how to move forward on that direction. As we said, today the focus is in the CS-FSTD, and one of the let's say differences that you will spot immediately is that the new CS-FSTD will cover both aircraft category, fixed wing and rotary wings. Today we have a CS dedicated to airplane and a CS dedicated to helicopter. Tomorrow we will have one single CS which will have one single concept. To better explain this, I will give the floor immediately to our colleagues, Colin and Eric, please.
Good morning. Good morning, everyone. I hope that you can hear me okay. I am Eric Fuyat-Weishaupt. I am the chairman of Rulemaking Task 196, and I will share this introduction, this information session on the CS-FSTD with Olli Hänninen. Olli, please.
Hello, everybody. So my name is Olli Hänninen, and I'm working as a senior inspector at Traficom. I've been working with this rulemaking task from the beginning, and at the moment I have the joy of leading the subgroup that is working on the new CS-FSTD.
Okay, so just to give a little bit of context on this rulemaking task, the work that we are presenting you today has indeed started in 2018, 2019, and we have been working on modifying the CS-FSTD at that time. We submitted a notice of proposed amendment in December 2020. This was NPA 2020-15, if you remember, and then it was open for comment, and then there was COVID. And then there was quite of a stop to a lot of activities, but it enabled people to gather comments on this NPA. And we received those comments, and there were roughly 500 comments on the CS-FSTD. So in 2021, 2022, we restarted our activity, and we decided to take into account those comments. And now the result of this is the new CS-FSTD that we will introduce in a few minutes. There will be a focused consultation on this CS-FSTD that is planned in September 2024, so in a few months. But the EASA management will give you a lot of information at the end of this meeting. So I will not spoil the suspense. So then we can move to the next slide, please, Olli. Olli, is it possible to move to the next slide?
Yes, sorry for the delay.
No problem. Thank you. So the CS will be published very soon. So we have finalized the document with Oli and all the FSTD team. This CS-FSTD relies on the concept of ICAO Doc 9625 with some significant differences. We keep all the concept of the features and the fidelity levels. We keep the fact that a simulator has to comply with general requirements and to fulfill objective tests and functions and subjective tests. So the global philosophy remains the same. And we have modified a few things compared to Doc 9625 and also compared to the NPA 2015 because we took into account the various comments that we received. So we are going to give you a briefing on all these aspects. And then we move to the next slide, please.
And this is the first major difference between the NPA and the new CS-FSTD. The number of the features is different, and the names of these features have been modified so that they are more meaningful to the FSTD users, meaning the pilots. For example, the words ground handling were first understood by the pilots as more like waste management and fueling at the airport rather than something related to the performance and handling. So the flight controls feature is split into two different features. One feature for forces and hardware, and another for the flight control system operation. Feature number 2 is all about the primary flight control forces and hardware. Please consider a fly-by-wire aircraft such as an Airbus. On the highest, the specific level, the used hardware could be, for example, a genuine Airbus side stick, as you see in the image. For this highest level, the flight controls should look and feel as in the aircraft, and the forces needed to move them should be very realistic. For the representative level, the controls should be very similar to the real aircraft, but the forces do not have to be as accurate. So at this level, the side stick could be simulated, and it could be, for example, something like you see in this photo. For the generic level, the controls should be characteristic to the simulated aircraft group. Perhaps even a simple controller could be used. And it's also possible not to have any flight control hardware at all. Naturally, the training credits for such a device would be very low. Feature number 3 then concerns the flight control system operation, how the flight control system behaves, perhaps what kind of protections it serves, how much the flight control surface deflections move, and so on. We have also completely reworked the requirements for ground and flight model. In the new CS-FSTD, we talk about flight regimes, ground, in ground effect, and out of ground effect. The ground regime concerns the whole performance and handling, so it combines all the aspects of the ground model and aerodynamics when the aircraft is on the ground. For example, when taxiing, during takeoff, ground run, etc. And the flight model requirements have been divided into 3 different features. There are reasons to do all of this. First, if you have only one feature for the ground model, as in the NPA, then your flight model covers all the flight phases. It means that you can't get the best level for this feature unless you simulate and validate also takeoffs and landings, but that is very difficult and expensive. So by separating into these flight regimes, it's possible to build a cheaper device that has the best flight model higher in the air, but is perhaps only generic for takeoffs and landings, so the training credits can be controlled and the expenses can be controlled this way. And for the users of the devices, for the pilots, the ground model has always been kind of a mystery. Perhaps they don't always intuitively understand ground model as engineers. When we combined the ground reactions and aerodynamic forces into one feature, we talk about performance and handling on ground. That is intuitive and everybody understands that. We have also removed the simulated air traffic control environment from the list of features. The reason is that it's not mandatory and there is still a very low number of devices that use this. We are still keeping the requirements in the CS-FSTD and they have to be followed if the simulated ATC should be installed and qualified. But again, ATC is just not listed as a separate feature. A qualified ATC in an FSTD would be listed in the certificate as an additional capability. As a summary, the work that we have done ensures that the features do not really overlap between each other, so we have split them apart as far as possible.
So, as an addition to the differences with the NPA 2015, we have taken the decision to get rid of the types and levels. In NPA 2015, we have presented a table like the one that you see on the screen that makes a distinction between FFSs, FTDs, FNPTs, and gives them levels according to their FCS, their FSTD capability signature. And in fact, this was kind of hybrid approach that was limiting the flexibility offered by the new concept. So we decided to get rid of the types and the levels in the new framework. Bear in mind that this CS-FSTD will be applicable only to new devices. All the existing devices are remaining in the existing framework. So this is an important change compared to what we are used to and compared to what was in the NPA. Next slide, please, Oli. There is also an important change that we have made. It is that the fidelity levels for each and every feature now, they range from generic, representative to specific. We provide a description and we provide requirements for all the fidelity levels, which was not the case in the NPA, which was not the case in DOC 9625. So all the features had their fidelity levels that range from N, G, R, and S. And we think that this makes the whole concept more homogeneous. And there is a clear understanding on the fidelity level and its meaning. There is something important to notice concerning generic fidelity level. Compared to what is in DOC 9625 and compared to what is in the NPA, the generic fidelity level is slightly higher. It is no longer a simplified simulation. It is no longer a basic simulation. Generic now means it is characteristic of an aircraft class or group. So this is to bear in mind also. And to make a very simple comparison between the old world and the new world, we can say that if we have all the features at specific level, we can say that this is today's FFS level D, roughly. There is no major change. And in fact, if you have a deep analysis of the requirements that we have put in the new CS, you will see that we do not go higher than what you already know for the FFS level D. This is today's limit on the top end. And if you have a look at what generic means compared to the existing framework, we could say that roughly generic means something that you use in an FNPT. So this is to give you an explanation about what we understand now with fidelity level. We can say that also the fidelity level for generic is slightly higher than FNPTs because we have seen that in the existing ecosystem of simulators, what is proposed by the industry is higher than the bar that is set by the existing requirements. So we consider that in order to fulfill training needs, we have to align to this and to make generic higher than what was in the previous NPA and .NET 625. So we can go to the next slide, Oli.
Yes, here is a screen capture from the NPA 2020-15. You see the objective test requirements there. They state that the listed relevant features must be on the same fidelity level, and this essentially limited the number of possible FCSs since they had to be on the same level. So to be direct, the system in the NPA just didn't work. You may have seen different kind of part task trainers that have only generic flight controls or maybe no flight control hardware at all. If they are built only for system training purposes. But today, many of those devices, they may have specific level aircraft systems and representative flight level flight models, etc. Now, if we would still require that all those features should be at the same fidelity level, we should basically enhance the lower level fidelities and capabilities and build them up to the specific level, to the same level as the aircraft systems. So instead of a part task trainer, actually you would be building a full flight simulator almost. As you see, the system presented in the NPA needed a change, and we wanted to have the greatest possible flexibility. So we have rebuilt the whole logic of how the applicable objective tests are selected, and you will see a separate page about that a bit later.
So now let's speak about the change in the scope of the features and the definition of the requirements. In fact, when we took a deep analysis of the content of the document and the comments that we received, we soon realized that there were a few places where there was a kind of overlap between the definition of the requirements and the feature to which they applied. This is just an example. So what you see on the screen is the feature that was called flight controls and forces. And in fact, if you have a look at the highlighted part, you can see that this requirement does not speak about flight controls and forces only. It also speaks about the flight model, the aerodynamics and the flight mechanics. So you can see that there is a kind of overlap. And we decided to split the features differently in order to remove this overlap. Now there is a clear partition. Each feature covers a set of requirements, no overlap, no gap. It's a strict partition. So next slide, Oli, please.
And as was mentioned earlier, the airplane and helicopter requirements have been in two different documents. And traditionally, the airplane document has always been updated first, and the helicopter requirements perhaps only some years later. So a decision was made to merge the airplane and rotorcraft requirements into one single CS-FSTD. The layout of the document has been carefully considered so that it would be readable and that the reader would understand what is applicable to airplanes and rotorcrafts.
And now I'm going to give very basic information, but I think it's almost the most important. In order to guide you in the reading of the document, you have to consider that it's really different from the existing CS-FSTD alpha, the existing CS-FSTD hotel. It is very different also from Doc 9625. It looks like what you have in the NPA 2015, and we have developed even more this concept. We have a clear split between subparts. There are 5 subparts, and we will describe them in a few minutes. And each subpart is based on tables and a clear split between requirements, and these requirements, they are covered by CS, and it is also covered by guidance material. And we have tried to illustrate as much as possible with examples and guidance all the requirements. And we think, and it's one of our main goals, it's to have requirements that are indeed requirements and that are not a mix between requirements and guidance. So we have tried to make a right split between the requirement and its guidance. So now we are going to have a look at the subparts of the document. So I'm going to share my screen. Please bear with me a few seconds. Can you see sub alpha displayed on the screen?
Yes, it's okay.
Please, you can send us a thumb up if you can. Can you hear me? Okay, perfect. Thank you. So let's speak about subpart alpha now. Subpart alpha is the introduction of the CS. It will be made of applicability information and a set of definitions. And it will also provide guidelines on how to use the document. So we explain the structure, we explain the scope, and we also provide all the definitions. And as we speak about a new framework, there are a lot of very useful definitions. For instance, the meaning of the features, the meaning of the fidelity levels, the meaning of correct range and magnitude, the meaning of essential match. Plenty of very useful definitions, we hope. Now it's time to speak about subpart Bravo. So I will stop sharing my screen. Over to you, Oli.
Yes, and so I'm going to give you an introduction to the subpart Bravo, qualification basis. So this subpart is dedicated to the qualification basis and general requirements. This subpart gives the highest level requirements, and and the other subparts kind of amend what is required there. So the other subparts then give details, for example, what testing is required to show compliance with these general requirements. The first important principle that I want to highlight is here. The principle is that you have to comply with all the requirements to gain a certain fidelity level. So it means that we don't have an almost level S or a little higher than representative level. It's strictly one of the 4 levels, N, G, R, or S. So you are either at the level none, generic, representative, or specific. There's nothing in between these. So it's an important principle to be included to avoid any wrong interpretations of the requirements. We said that we have isolated the features. Yes, we have isolated them, but the requirements, they are not overlapping with other features. Still, we can't consider the features in full isolation. The complete training device should have an FCS and levels that make sense. For example, it would be just silly trying to build a device with the specific level of flight model, but the lowest level of flight controls. Actually, also the training requirements kind of mitigate this problem because it would be indeed silly to have such a combination. As you see here, this framework allows that the aircraft systems may be at different levels. We do this to enable all sorts of part task trainers. You don't need all the aircraft systems. If you are interested in giving training only with some aircraft systems, still, also these systems can't be considered in full isolation because often the aircraft systems integrate with each other. If the device has the aircraft systems at different levels, then the documentation of the device must declare this, and also the training requirements tell you what systems are necessary for the training tasks that you are planning to do. In the current requirements, the statements of compliance are required only for some topics. Now we are introducing a new concept. We require a statement of justification for all the general requirements. We are deliberately using the word justification. The reason is in the semantics. For the current statement of compliance, you can basically just say that, yes, we do comply. But the statement of justification means that you should give more information to tell how you are fulfilling the requirement. We understand that these statements will result in more work, but it will serve as an audit trail. It will close the loop. It will create a documentation that tells if and how something is simulated. This tries to answer to a very common problem, because it is too often that a device is qualified and only a few years later it is noted that something does not work in the FSTD, and nobody is able to tell if the thing was ever even simulated in the first place. So the statement of justification is given to all the requirements so that you can always refer to them, seeing if and how something is simulated. The statements can be simple, for example, telling that the OEM data package is used and requirement is validated in the QTGs. But for generic fidelity levels, the information needs to be more comprehensive because there are so many different ways to simulate generic fidelities. The CS-FSTD gives you also examples and guidance on these statements of justification. This is a sample page of the general requirements. I will introduce you to the layout that we are using. The requirements are given for each feature under a separate subtitle. We believe that this is a more readable format than having just one lengthy table as in the NPA. The gray box on the top gives you information on what this feature is all about. It gives you also any other important information, such as the notes that you can read here. We use subtitles to tell if a section is applicable only to airplanes, helicopters, computer-controlled aircraft, and so on and so on. And then you have tick marks to tell if this requirement is applicable to the fidelity level or not. We have added a new column, verification and validation. These columns tell you how this requirement shall be checked. Here we see that this requirement is associated with QTG tests in sections 2 alpha for both airplanes and helicopters, and that you should also check this by functions and subjective testing. These columns help you to understand the big picture and to track the testing back to the requirements. You can easily see that for many requirements, QDG tests are required only for higher levels, but not for generic level, where only functions and subjective testing is enough. These columns also serve the industry with the statements of justification. Now everybody knows what kind of verification and validation is expected, so preparing the statement of justification becomes very straightforward. We acknowledge that the general requirements are still long and detailed. Therefore, we have summarized them also in easily understandable and very short descriptions for each feature. These words are written to be meaningful, especially to the users of the device, again, meaning the pilots and instructors. They have to understand what each feature and different level means. This is an effective way of sharing that information. We are adding this kind of information as guidance immediately below the general requirements. The same guidance is also added to the training requirements, so that the pilots read more than the CS-FSTD. As you see, we acknowledge that this change is huge, and we are using guidance material in helping all the stakeholders to understand what each requirement and process really means. So this ends the introduction to subpart. Bravo. Eric, back to you.
So I will speak now about subpart Charlie. Subpart Charlie is new compared to what was presented in the NPA 2020-15 because we received several comments requiring more explanations on the sources of data that can be used depending on the fidelity level. In fact, we decided to create a brand new subpart. We call it engineering justification. And indeed, what we speak about is about what is known currently as the engineering report, and also about the validation data roadmap. And if we are used to the validation data roadmap on higher end devices today and to the engineering report on FNPTs, for instance, from now on with the new CS-FSTD framework, there will be a requirement for both documents, whatever the FCS. There will be an engineering report even at specific fidelity level. But if it is at specific fidelity level, it means that probably aircraft manufacturer data are used, real flight tests are used, so maybe the explanation in the engineering report will be simple. On the other hand, at specific level, you might have a lot of information about the origin and the context in which this flight test data was recorded, but this will be in the VDR. So we have to consider that the VDR and the engineering report, they are on the scale. If you are at specific level, the VDR weighs more than the engineering report. And if we are at generic level, the engineering report weighs more than the VDR. So this is a kind of balance that we need to have in mind with the new concept. The two documents complement each other indeed. Now, here is a quite important table. It is a table that explains for each category of validation data source, depending on the fidelity level, what is acceptable. So this is the core of subpart Charlie. And you can see that there are a lot of possibilities for the sources of data. And for each fidelity level, we add a tick mark in the column where this is a valid source of data. So this is something that we hope clarifies really what is expected as source of data for the validation of the sim. We also give a lot of explanation in subpart Charlie on, yes, okay, Warren. We also give as much information as possible to clarify what correct trend and magnitude means, especially in this concept. Now, there is another topic that is quite important for the subpart Charlie, is that we give an example and of a VDR, an imaginary VDR for a generic fidelity level. So this is typically what this could look like. And for the time being, you don't have that. So the idea is to clarify what we mean and what we use. For instance, for this QTG test, we use CS-23 data, we use subjective development, we use the footprint method, etc., etc. So this is what we hope will clarify a lot what we want to use as acceptable validation data for a sim. So now we move to subpart delta. I will stop sharing.
Thank you, Eric. And subpart delta, it gives all the requirements on QTG tests. I will brief you on the main aspects that are necessary to be understood on this entity. As you remember from the beginning, we don't require that the features should be at the same level. While this brings flexibility, it also creates a bit more complexity that has to be controlled and understood. The first aspect is highlighted here. This means that you may have the features at different levels. When any objective test is applicable to your device, the test shall be within tolerances. We don't give any alleviations to this. For example, if you build your device with only generic level flight control system, but you aim for specific performance and handling, it is a combination that may lead to problems on many objective tests. It is likely that the tests cannot fit within tolerances with such a combination. In such a case, you should just enhance the flight controls simulation as much as is necessary until the tests can be demonstrated to be within the tolerances. Another important principle is that we are fixing a problem with the objective tests. Today, our regulation gives tolerances on the output, like how the aircraft attitude changes, but the regulations today hardly say any word about the test inputs, how well the flight controls and initial parameters should match the validation data. In this example that you see, it's a good match on the test output. It's nicely within tolerances, but if the input is like this, we should really not approve this test. As a summary, we need criteria on the test inputs as well, and we have added this into the CS-FSTD. This is part of the new requirements. You see that it uses the words essential match. It means basically that the FSTD is the same as the validation data. I mean the FSTD result is the same as in the validation data. Please stand by. There will be a yet further page on the essential match coming soon. This is an example of the objective test requirements tables showing the beginning of one section. Each test section has a separate subtitle and separate table, and all the guidance associated with the tests in this section is attached immediately below this table. This way the guidance and requirements are kept together and the reader finds them easily. Some sections are common for airplanes and rotorcrafts. For example, some visual tests are such. but most of the tests are different between airplanes and helicopters, so we use the letters A and H in the titles, and we also use the complete words for airplane and rotorcraft in the titles as well. Now to the tests itself. I believe we are all familiar with the flight control sweep tests in section 2 alpha. We have created a system where all the tolerance parameters have been pointed to the feature that they primarily validate. These columns then tell both the tolerances, but also if the test is applicable to your device. Let's see an example of this logic. So please consider an FSTD that has the features Flight Control Forces and Hardware, CLH, and the Flight Control System Operation, CLO, at the lowest generic level. In the column for G, we see tolerances only for the lower test option. This means that the upper test is not applicable. I am highlighting that here with the red color to indicate that, but the lower test is applicable. It should be included in the master QTG, and naturally, it must be within tolerances. Now your next question is about the tolerances. What do these acronyms in these cells really mean? Let's review them next. This is a good example. We are still reading the same test for a sweep test. For the representative level, for initial qualification, the meaning of master, for the initial qualification, it means the approval of the master QTG. The elevator angle tolerances are CT and M, meaning correct trend and magnitude. So there should be appropriate validation data to support this test, and the FSTD should correspond to that within correct trend and magnitude. For the recurrent tests, the annual tests that you perform, the FSTD should show essential match to the master QTG. We abbreviate the essential match as EM, Echo Mike. The elevator angle is calculated by the software based on the control position, so it should basically not change at all, even during the time when time passes by. So an essential match is expected. We give criteria and guidance on the essential match. Let's discuss the benefit of the essential match concept yet further. This is a typical example of a crosswind landing test for an airplane FSTD. The bank angle has fluctuations due to the wind. It's very difficult to perfectly simulate the wind conditions on this complex test. Consequently, the test is momentarily out of tolerances at some spots. I guess that most of us would still use engineering judgment and decide that the test result is still acceptable, so we can approve this test as the master QTG. But the same question about these highlighted points still rises for every single recurrent test. The test engineer and the evaluator waste their time when they have to open also the master QTG binder to compare the recurrent to the master. For this reason, the CS-FSTD requires that the recurrent QTG test should show also the master QTG result. Many device manufacturers do that already today and have done that for many, many years, but we want to make this as a standard for all the devices. In this example, you see what the recurrent QTG graph could look like. For the recurrent test, we are primarily comparing the recurrent to the master. Still, the validation data should be there also to support the analysis. We can see that the recurrent and master results are basically overlapping, but let's zoom in a little closer. Yes, The recurrent and the master QTG are overlapping almost pixel by pixel. This is an essential match. Now, we don't need to interpret the results or use engineering judgment. We are just comparing if the device is able to repeat what was originally qualified. Most of the new devices today are perfectly capable of showing essential match. This principle is not a new thing. We are just implementing that as official language and as the primary method of checking recurrent test results. I still return to the QTG table in the CS-FSTD. This is another example of the tolerances. These tolerances apply to the control flows. That depends both on the software and also on the hardware. And hardware naturally wears out during the time, so we cannot require an essential match for the recurrent tests. So we say that for the recurrent tests, the same tolerances apply as for the initial qualification. For the specific level, the tests and tolerances are pretty far the same as today for a full flight simulator level D, as was mentioned. Levels R and G are quite close to today's FTD and FNPT devices, but they have been reconsidered and modified, and the test requirements are based on the training requirements as well. As I mentioned, below the test requirements table, we give all the test requirements and information. First, we have this kind of a table giving information or requirements for all the tests in the section in question, followed by another table where we give detailed test requirements for each individual test. I hope that this gives you an understanding of how the QTG tests or objective tests are selected and how the tolerances are interpreted. The CS-FSTD naturally gives textual requirements and guidance and more information on all of this.
So now I will speak about the functions and subjective test, subpart echo. And as in the rest of the document in the CS-FSTD, we try to keep the information structured so that you don't have to navigate from one page to 200 pages later, etc. So we try to keep the information at the right place and at the right level. For the functions and subjective test, it is still the same philosophy as you already know, but we emphasize that in fact, with the flexibility that enables the FCS concept, there must be a greater consideration taken by the FSTD organization and the people who design the functions and subjective test program. They have to consider what the FCS of the device is. For instance, if you have a device that has specific performance and handling features, and that has a generic visual system, you might have to consider the way you validate and the actions that you put in place to validate your general requirements. And this is not a one size fits all. It is something that has to be adjusted to the FCS, adjusted to the capabilities of the device. So it's what comes with the greater flexibility. And in fact, there needs to be a good assessment of the device when designing the functions and subjective. And in order to help in this process, we provide information on how to do it. And there is a process that is described in the CS-FSTD. So there is a typical, what you see on the screen, the FST 010. It is explaining exactly this process of how to design the FNST program. And we also provide guidance afterwards, but clearly right from the requirement level, I'm going to use the mouse, right from the requirement level, the CS, you have explanations about, in some cases, you will have to remove some tests that are not applicable. You have to expand the list, so to add tests, and you have to adjust the list of tests depending on the operation of your aircraft systems. So everything is listed in a structured way to explain all that has to be covered in the FNST. And as it is something that is, I think, better explained than in the past, we also consider that it's very important to provide guidance on this. And we explain in real cases scenario what should be done. So very basic examples sometimes, but for instance, if your device simulates a single engine aircraft, you have to adjust your function subjective test, and some items that are applicable only to multi-engine, you remove them. And it is your own responsibility as a user to have this list tailored to your simulated aircraft and to your FCS. This is a very important topic. And now I will give back the mic to Oli to cover the end of the presentation. So please bear with me.
Thanks, Eric. So should we jump to the last slides?
Yes, please go ahead. I have to stop sharing.
Yes. So yes, now it's flowing, and a few more slides. So now we have covered the structure and main principles of the new CS-FSTD. But I wish to highlight one more aspect. It is about the extended reality, meaning virtual reality, augmented reality, and so on. This entity is a hot potato, as we all know. We need detailed requirements for that, but we don't have them yet. However, EASA has already qualified some devices under the special conditions arrangement. The guidelines for the special conditions have been published on EASA website, so it was natural to take them aboard as they are today. It is still only a starting point. This section that you see is a top-level summary of how to qualify an FSTD that uses extended reality technologies. EASA is planning to continue this work with the extended reality matters topics, so it seems that EASA and ICAO are also doing parallel work, and in the next revisions we would see really detailed technical requirements, while today we only have more like a process and only the top level requirements in this CS-FSTD. So everything that already exists in the mentioned EASA guidelines have been incorporated into the requirements and tables themselves, as you see in this sample. This sample lists the existing policies for extended reality, but again, it still only acknowledges that special conditions need to be followed, and the requirements for the special conditions can be found in Part ORA. Now you should be able to understand the main aspects of the CS-FSTD. The CS-FSTD is not absolutely perfect yet. There will be a focused consultation of the CS-FSTD in the future. And as a colleagues, I give the floor back to you. So thank you everybody for participating, and we're looking forward to your feedback on the CS-FSTD.
Back from the room in Cologne, we would like to thank very much to both our presenters, to Oli and Eric, for the wonderful presentation. I see that also some other people expressed their support on what I said. We would like now to walk you through the next steps. As we have seen also some questions raised during the presentation that you are interested to get the presentation. Of course, we would like to make it possible, and it's our intention to make it available on the website where you can also register for this event. We also would like to say that we organize a parallel recording of this event so that this video will be also available there, and you can also review it during any other time that you need, or maybe some more colleagues might be interested. So we would like to raise as much as possible awareness of this major deliverable, and that you can have a chance to follow it later on. Now I would like just to walk you through the couple of slides that we have as regards next steps of this rulemaking task, and also the CS, the draft CS that was just presented. As announced earlier from my colleagues in the rulemaking team, we have started the journey quite a long time ago, but for us a major work that we use now to finalize the efforts on this rulemaking task is the NPA published 2020, and all the comments which were very valuable, and we estimate and we assess in order to improve our work. Based on that, as you can see, we have a series of work done in the years, and very intensively this year and last year. Last year, if you have followed this information session, we revamped the presentation of the whole development of this rulemaking task. This was followed by several focus consultations on presentation of the proposed hard law changes. Today, we have an opportunity to follow this new draft CS, and that would be followed by a focus consultation which is planned in September to provide comments on this draft FSTD. There will be also several focus consultations for the soft law package, the so-called acceptable means of compliance, and the guidance material, which are for the whole air crew regulation and the air operation rules. To align and make possible for as well to operators to follow this opportunity. And that is followed by two major events in our planning in 2025 and 2026, where EASA will issue its opinion on proposing to the Commission the hard law changes, and 1 year later will also issue the accompanied acceptable means of compliance and guidance material related to this hard law. The intention is that they will be simultaneously enter into force, so the whole package of hard law and soft law will be made applicable, entry into force at the same moment, and applicability that we target is 2 years later, as you can see, 2028. We would like to use these 2 years for very intensive support that we can provide to our stakeholders. And I give now the floor to Ascanio Russo, who can guide you through this implementation support.
Thank you, Nadia. Thank you. In fact, this will be a major change with some complex concepts that have to be understood before moving. But let's also say that we have two different streams, let's say. In the CS-FSTD, once the regulation will become applicable, then this will be mandatory regulation that has to be applied for the building of new FSTD. While for the training part, we have to remind that this will be mainly a voluntary path that can be discussed at organization and authority level. Having said that, we believe that the two concepts have to be fully explained by EASA in terms of how this can be, from the training perspective, how this can be built, the new training design, but also the benefit of the new training. So in the 2 years that Nadia was mentioning before, we are planning to have implementation session, mainly webinars like the one today, with a bit more interaction for sure. And we are planning to have a dedicated session for authorities, for training organization, but also for FSTD organization and manufacturing. This will help all of us to move through this new direction and to implement in a standardized way the concept, hoping that this will be again well received by all industry, and this will produce better training, but also better device, more useful and more usable for the tasks that we want to complete and to have at the end a better result. Having said that, on behalf of the entire rulemaking group 1 and 6, Francesco and all EASA managers, I would like to say thank you again for your participation, and we wish you a nice rest of the day.